Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 48, Liquids and Solids, Part 3. Here are our objectives for today's video. Pause here. You do not need to draw the picture. So the goal of today's video would be that you could look at either the formula or maybe a small picture of a molecule or atom and determine what type of solid it is. The reason why we care about that is because the different types of solids will have different types of properties, so we can make predictions about something just by looking at its formula. So the first type of solid is an atomic solid, hence the word atom. So this will consist of things that are just atoms. Because they're just atoms, the only force they can have are London dispersion forces. Iodine, charcoal are examples. And you're probably thinking to yourself, isn't iodine a Hunkelbreth? Therefore, it would be diatomic and not atomic. And that is true when you are in the gas phase, but not necessarily in the solid phase. These will typically not conduct electricity. Pause here. You do not need to draw the picture. Right, so our next type of solid is a molecular solid, very similar to the atomic, but instead of having atoms, we have molecules. So they are held together with London dispersion forces, though you can also have dipole-dipole or hydrogen bonding thrown in the mix as well. Dry ice, which is just CO2, or graphite, which is in the picture, which is an allotrope of carbon that is a molecule. And the molecular solids are typically not going to conduct electricity. I'm sure there's exceptions to literally any of the general guidelines that are on here, but generally speaking, they don't conduct electricity. Pause here. You do not need to draw the picture. So we talked about the properties of metals like way back in probably October or November, depending on how things went this year. I'm recording this over the summer, so I still have no idea how coronavirus is going to affect things. But let's just assume that you've seen this in November. We talked about properties of metals. We talked about an electron C due to loosely held S and D electrons. Well, that is also sometimes called metallic bonding, the sharing of electrons. And that is a pretty powerful intermolecular forces. So you're going to see this conducting electricity because we've got the moving electrons. We're going to see these being shiny. And typically they'll have pretty high melting points compared to atomic solids or molecular solids. Pause here. You do not need to draw the picture. And then the fourth type of solid, which is a covalent network solid. So this you'll typically see with things like diamond, quartz. Silicon can do this. You'll see a lot of the group 4 things can form covalent network solids. This will occur when something can form multiple covalent bonds to the point where it creates a huge molecule. It's sort of similar to a polymer. And because we've got a huge molecule, we've got a high molar mass, we've got a lot of electrons, we've got high London dispersion forces, but it is still London dispersion. So despite the fact we've got really, really strong intermolecular forces, this will not be able to conduct electricity. Pause here. I'm going to talk my way through it. If you can look at it and just figure it out, feel free to fast forward through my explanation. So the first one, lattice of positive and negative ions held together by electrostatic forces. Right away, positive and negative ions, it tells me this is ionic, so cesium chloride. Second one, closely packed lattice with delocalized electrons throughout. Delocalized electrons tells me that I am looking for a metal. Gold is the only metal on the list. Third one says strong single covalent bonds with weak intermolecular forces. So the fact that it says single covalent bonds gives away to me that I can't have double bonds. Therefore, this is going to be methane CH4 because CO2 has the 2 double bonds. And then the fourth one, well, process of elimination will tell you it's CO2. You don't need to worry about the pi bonds thing. That's something we get into in AP Chem, but it also fits the bill for CO2. Pause here. You absolutely do not need to draw this picture. So phase diagrams are something that I want for you to be able to look at and be able to use them, but it's not something you're ever going to need to be able to draw. So these don't just take into consideration temperature, because typically when you hear boiling point, melting point of something, it's the boiling point and melting point at atmospheric pressure, but there is different melting points at different pressures. So sometimes you'll see these axes swapped with the pressure and temperature. That's completely normal. But the common thing is that liquids are usually going to be their own sort of triangle. When you have your higher pressures, you'll tend to see more solids. Lower pressures, you'll tend to see more gases. These are just things to keep in mind, because once in a while you'll see one that's not labeled. It's here. Right. So when I look at this, I can tell right away that this section here is going to be my water, or my liquid rather. It doesn't specifically say that it is water. And then at higher pressures, you're more likely to see a solid. And at lower pressures, you're more likely to see a gas. So over here is my solid, where my cursor is right now. And then down here is my gas. So it's lower pressure, you're more likely to have a gas. And now we're looking for the equilibrium between the solid and the liquid phases. So my solid and my liquid, they intersect at this point here, C. So that is why the answer could be C. And then it says equilibrium at normal melting point. The reason why it's normal is because we're at 760 millimeters of mercury, because some of you are probably wondering, well, why not B? And the reason why not B is because that's at a much lower pressure. That's not at atmospheric pressure. Also, that's the triple point. Triple point is when you have three things coming together. You're not typically going to see it in real life, but it can exist in theory. All right, thank you so much for watching and have a great night.